Hello, boys and girls, and we are going to be starting topic 11 now. We've spent a lot of time on division, and you're probably hoping that we're done with it, and we are taking a break from dividing. However, we can't forget all of that stuff that we just learned. But we are going to be changing pace a little, and we're going to start working with fractions in topic 11. Um, but before we get into fractions, we are going to take a look at um, reviewing a few things that will help us when we get into fractions because in fourth grade we really start looking at equivalent fractions or fractions that are the same and numbering and ordering those fractions. So there's lots of different things that we need to have in our toolbox to help us figure out how to do those things. So today's lesson, we're going to focus on three words that you've probably heard before. We're going to start with multiples. And we're going to use this word problem to help us figure out what multiples are before I actually give you the definition. So it says there are 9 students in chess club. Okay. The club wants to buy the same number of each item for each member. What number of items might the club buy? So there's 9 students in that club. Okay. And they want to buy each of those members the same number. Okay. So meaning if I have 9, I'm going to write this out here for a minute. So if I have 9 members, say I wanted to buy each of them one item. Let's say we're buying them tickets to go out to like Chuck E. Cheese or something like that. Okay. If I buy them each one ticket, I would have 9 tickets, right? Okay. I still have those same 9 members. Now I want to buy them each 2 tickets. This would give me 18 tickets now because we were taking 9 people. We're giving them each 2 tickets. So it would give us 18 tickets total. We're taking our 2 parts and multiplying them together. We're going to do 2 more of these. Let's say I have 9 members still, my 9 students in chess club. We're going to give them, they did a really nice job. So we're going to give them each 3 tickets now. So if I gave them each 3, we would have 27. We're going to do one more. Let's say we have those still 9 club members. And now I'm going to give them each 4 tickets, and we would end up with 36. Now, you're probably saying, Mrs. Jank, we're just counting by nines, really, right? We're just saying 9 times 1, 9 times 2, 9 times 3. We're just working our way through the nines multiplication problems. But what I want us to look at is the numbers that we were ending with over here. Okay? These are what we call the multiples of these problems. The numbers we were multiplying together here were the factors. We were multiplying the 2 factors together to get the multiples. So the multiples are not of 9 are 9, 18, 27, 36, and we could keep going forever. Okay? So multiples are the numbers when you're counting by that number. So when we say count by fives, for example, and you start counting 5, 10, 15, 20, 25, 30, and I'm going to stop there. I could keep going. You're counting by the multiples of 5. Okay? Same thing when we say, okay, count by twos. You start going 2, 4, 6, 8, 10. Those are multiples of 2. Um, so multiples are something that you already use and already know what they are. You may have just not remembered that that's what they are called. So multiples are when you are counting by that number. Other things we'll look at, like multiples of 10, 10, 20, 30, 40. We notice that all these end in zeros. You're going to start noticing that some multiples follow a pattern so that you know you're writing down the correct multiples for that number. Okay? Now that we know what multiples are. So multiples are the numbers that we get when we multiply. So the product, basically, of a multiplication problem, just like we were doing here. Earlier, I said these were our factors. That's the next page that we are going to go look at is our factors. So here's our word problem to help us with our factors. It says Jared has 12 flowers, okay? He wants to plant them in equal rows. I'm going to box that in his garden. What are all of the different ways he can arrange the flowers in equal rows? And I want you to think of the word array here. So before I even write any numbers on the screen, I'm going to draw a few arrays. So I have 12 flowers. Well, I could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have one row of 12. Okay. I could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I have 2 rows of 6. I could also do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I have 3 rows of 4. Okay. Now I could switch this around and I could do 4 rows of 3 and I could do 6 rows of 2 and I really can't change the top one of the one row by 12. Or I could do 12 rows of 1. Really, I could just turn all of these arrays to change them around, but they still are all going to equal 12, okay? But what I've done here is I've created some factors of 12. I really have 1 times 12, right? 2 times 6, and 3 times 4. All of these numbers equal 12. They're all different ways to get 12. Okay, and this is where this is different from a multiple. Remember, the multiples were the answers or the product. I'm looking at my factors. I'm looking for the numbers that we multiplied to get to 12. So I could say 1 and 12 are factors of 12. 2 and 6 are factors of 12. 3 and 4 are factors of 12. And a way we could write this out is I could say, here's my 12. Okay, this is the number we're getting to. I can do 1 and 12, 2 and 6, and 3 and 4. We call this a factor tree, so I really could start drawing some branches out if you wanted, okay? But it's a factor tree, so we are listing our factors out this way, okay? Let's look at another example here real quick for factors, because this one gets to be a little bit trickier. So let's say I wanted to look at all of the factors of 10, okay? Start at 1. We know that every number multiplies by 1. That won't change. I can always start with 1 and say, okay, well, I can do 1 times 10. Okay, I'm going to move to 2. I know that 2 times 5 is 10. Okay, now I think to myself, well, 3 can't go into 10, so there's nothing times 3 to equal 10. There's nothing times 4 to equal 10, and I've already used 5. So these are all of the factors that I could list for 10. Okay, so 1 and 10, 2 and 5. Let's get a little bit higher of a number. Let's try 24. Okay, again, always start with 1 and the number. That's always going to be the first factor you should think of. And then just move through. I think of 2. Well, 24 is an even number, so that I know 2 must go into it, and 2 times 12 is what equals 24. Now I think of 3. Well, I know, well, 3 times 8 is 24, so I'm going to put my 3 and my 8. And now I move to 4. And I think, okay, I have 4 and 6 equal 24. And then I think, well, I'm at 5. No, 5, 6. I already used 6. So I've listed all my factors for 24. All right, we're going to take a break there, and I'll do a second video for our prime and composite.